In problem 10.3, we are going to be asked to sketch a graph of a polynomial that has a few different properties to it. First, that polynomial has to have three different zeros, or in other words, three different x-intercepts. And it has to have this be true. F of x is greater than or equal to 0 for every value of x. So what does that mean? This just means our graph has to be above the x-axis at all times, because we need y to be positive at all times. That's what that means. So, three different zeros. Let's go for it. Let's just grab a couple. Three different zeros. I'm going to grab one right here, -2, put one right here at 4, and one right here at 8. So there's our three different zeros. And now this is the tricky part. I need my graph to always be above the x-axis. Well, if I start above the x-axis, that helps. And I know that even if this is my 0 here at -2, I can stay above by bouncing off. And actually, I can just do the same thing at the next x-intercept. I can bounce off, and I can do the same thing in the next x-intercept. So now I never go through the x-axis down to the bottom side. Right? I never want to do that because that would give me a y value that was negative, and I want all my y values to be positive. So there seems like a sketch that has three different zeros and always has positive y values. So here's the question. What is the smallest degree this polynomial could have? Well, I know in order for it to be a bounce at those x-intercepts, that means it must have been a multiplicity that was even. And the smallest even number is 2, which means that if this has a multiplicity of 2, and so does this, and so does this, that's going to give me a degree of 6 as the smallest possible degree. So let's try to write an equation here. If I have x equals -2 as one of my x-intercepts, that's going to give me x plus 2 as a factor. But remember, this has to have a multiplicity of 2 at least, but it has to be even, so I'm going to give this squared. Next one, x equals +4. Well, I can write that. That's going to be x minus 4 as the factor. And again, it also needs a multiplicity of 2 to have that bounce. And then for the last x-intercept, x equals 8, well, that's going to be x minus 8 as the factor. And it, again, needs an even multiplicity. It could be a power of 4 or 6 as well here, but I'm just going to use 2. So here's our equation, y equals all of that stuff. Let's try to see if our graph actually works. Let's go over to Desmos. And we're going to go ahead and type in our equation as x plus 2 squared times x minus 4 squared times x minus 8 squared. And this is a crazy looking graph. I'm going to make it unbolded. There we go, we can see a little better. But we can see, even though it's kind of difficult, we have that bounce there every time. Comes down, then bounces right back up. And more importantly, we have three different x-intercepts, but none of our y values are negative. Nothing ever shows up down here. All of our y values are up here. So it seems like our function we made up does work for having the properties they told us at the beginning of the problem.